Okay. There are a few more topics I want to cover. Somehow I feel like you guys are really tired. So do you guys need a break? Should I cover this very quickly or? So okay, to inspire you a little bit, at least for the feeless transaction people, who all are doing feeless transaction? You are doing? So what I'm going to cover in this actually can be used for feeless transaction. Uh, there is something else I will cover that, so imagine you have, I think somebody asked this question. Uh, when the voting period gets over, you want to unfreeze account, everyone's asset that is frozen and give it to them, but that's very expensive to do on chain. So the user has to unfreeze by themselves, right? And there is a nice way to achieve these things with some new frame APIs that are very experimental, but you can try if you want to. Okay, I'll try to cover it very fast. No? Very slow. Slow? Okay. Actually wanted to show you or go through the frameless assignment to give you more context. So you implemented tip and nonce in your frameless exercise, right? And you can think of this, it's a pre-dispatch logic, right? And you might have more pre-dispatch logic. So in Polkadot, we do some kind of checks that the sender account should be something, or we didn't do a fees collection, right? We did tips and nonce, but we also need to have some kind of fee collecting mechanism in our runtime. Did anybody look into the Polkadot and see how nonce and tip is actually implemented? You did? No? Okay, let's go through your old assignment. This was our apply extrinsic function, and what we did was before we do dispatch, we do some pre-dispatch checks, right? And what we wanted to do here, we did some nonce check, we did some tip collection. What else we did? Signature verification. Okay. I can actually ask you a question. So we use nonce to avoid replay attacks, right? Can you think a payload that is executed in Kusama can be taken and replayed on Polkadot?
No, there are other mechanisms which can prevent it. Like
what mechanism can prevent it?
The context parameters in the signature. So it is for one chain that specifies some chain ID.
So what is the context?
Context can be chain ID.
But I mean, somebody can create a chain ID with the same ID, right? Like you need something more unique to a chain. Genesis hash. So what you can do actually, as part of your signature, you can sign against a Genesis hash. And you just need a signature because the chain always knows its own Genesis hash, right? And you can make sure that the hash is exactly like you unload it and you check that Genesis hash was signed, right? This way you avoid replay attacks across multiple chains. So these are all, if you have worked with Golang or I don't know, Express.js I've heard, these are kind of middlewares. So if your request comes, before the actual logic gets hit, you do some kind of middleware checks, right? It's kind of similar. And we want some similar functionality in our runtime. So if you looked at the shared types that we have, what am I looking for? Extrinsic. It was of type unchecked extrinsic. Did anybody look into this? What is this type? What does it do? So there is this unit type that is passed here. This, what is it? The extra. What does that do? Did you look into it? Do you want to answer? It's a sign. So I'll show you. So it says it's called extra, which is of type signed extension. And we'll go through this, but I also want to show you something else quickly. If you look at signature.verify payload, actually it doesn't show up here, and it was unit type, so it doesn't matter, but the actual payload that you sign is actually this the thing that you see in the generic, the extra parameter, it's also signed together. And we'll look at what is signed extension. So if I can go back to my slides. Yeah, I just wanted to show that there is this pre-dispatch phase where we want to add these extra logics, and then you have the dispatch logic. Okay, so there is something called signed extension. It's called signed because you sign this extra data with the signature, and it extends your transaction checking capabilities, right? Okay, let's look at the code now. Let's look, what do you want to look at? Let's look at nonce, how nonce is checked in Polkadot. If you look at your template for this frame assignment, you will find this in your runtime as well. And if you see, there is different type of signed extras. Now, let me go through what is this signed extra. So we have some signed extension called check nonce, which is added to our unchecked extrinsic type. And somewhere we should implement this signed extension for check nonce. Let's look at the trait. So this trait has additional signed. Okay, we don't care about that. There is a validate. So you can imagine this is called while you're calling the validate pool for the extrinsic, right? So you want to determine your providers and consumers, or priority, right? Pre-dispatch. So this is called before we do the apply extrinsic. So this is a pre-dispatch phase. Validate unsigned. If it's the calls are unsigned, these are not important. There's a post dispatch. I will show you exactly why post dispatch or how fees calculation is used for using signed extension. There's something called metadata. So let's look at the whole cycle. We went to check nonce. Let's look at the implementation. So at pre-dispatch, what it does, it looks at, it reads the account. It does some providers insufficient, so you don't need to care about that. And it increments the nonce once it's there, but okay, sorry. We need to look at the pool validation, right? Because there is provides and requires in pool validation. And I think your code must be almost similar. So what it's doing, it's checking that nonce should not be in past. It's putting provide as the current nonce of the account. And it's filling require if the account nonce is not same as the past nonce. It puts something, the current nonce -1. If that nonce is equal to the account nonce, it just puts nothing. Did you do the exact same logic? Does it make sense or not clear how this is working? So there is this signed extension which checks some particular account should not be allowed to transact. You can read up more about it, but I'm not going to cover. But there's check spec version check, transaction version check. There's this check genesis which stops the replay attacks across chains. There are some other things. There's this charge transaction palette. So does anybody know or has anybody figured out how the fee collection works? For people who are doing feeless transaction, do they understand the flow of fee collection and substrate blockchain? Or in Polkadot relation at least? You wanna try? Huh? I'm not sure. But do you wanna try?
Yeah. I think how it goes is the fee is collected from the user that is sending the extrinsic first, according to the weight of the code.
What do you mean first? Like in extrinsic?
Like
dispatch phase or pre-dispatch phase?
Pre-dispatch.
Okay.
It's collected there, then the extrinsic, if the user has enough fee, the extrinsic gets executed, and then after that you could, according to your functionality on your palette, say if you want to refund some of that money to the user if you did less execution than what you were thinking, or if you just want to offer the free transaction.
Right. But how will you now do this? So what, if I understand you correctly, you want to put whatever extrinsic you have that you want to make it free.
Yeah.
You will put some weight to it, right? Some worst case weight.
Yeah.
And that weight is deducted first in the pre-dispatch phase.
Yeah.
Is that correct?
Yeah.
But for some user, you want to give it for free depending on some condition that matches. So
Yeah.
if they have some weight credits, you want to refund that, right? Or you don't want to like collect any fees if some condition matches. Is that correct?
Oh, from the start.
So
From the start in the pre-dispatch, you mean?
ideally, wouldn't that would be
I mean,
nice?
yeah, that would be ideal. Yeah.
So how are you doing right now? It will collect some fees, but it will refund. But imagine I don't have any money, but I have some weight credits. I don't have any free money, but I have weight credits. How will you implement that? So this is your answer. I will show you how the cut. Do you have a question? Okay. I'll just finish. So once we go through this signed extension, how fee collection works, and I'll show you one more primitive. Hopefully you can use that to implement your feeless transaction. Yeah.
Does the charge transaction payment specifically work with like the native asset, or because I remember reading something else about like charge asset transaction payment? Is that like a separate signed extra, or is it the same? Because it's one that allows you to use sufficient assets.
I mean, I will have to look into it, but I mean, it's just a implementation, and I think it will have its own configurations. And you could configure it to work with other assets. But I can have a look after the class to see if you can make it work. Okay. Okay, let's look at this. So first thing, what we do, fee collection in the pre-dispatch phase, we check the worst case weight, right? So you remember your extrinsic flow, you give some weight in your in the macro pallet weight something that is your kind of worst case weight, and then you do some execution, and if you think it charged less than what it is, you return like the actual weight consumed. The extrinsic does, so one thing important to note here is the extrinsic does not know anything about the fees. It knows only about the weight. And weight to fee is converted in these pre-dispatch phases. Pre-dispatch and post-dispatch. Is that clear? So, okay. So first you take some worst case weight, you do some extrinsic, you return some kind of post-dispatch information that how much weight was consumed, and at the end you refund some fee if you have collected more fee than you should have. So let's look at how it does it. So there should be a pre-dispatch something. And it just says, okay, withdraw fee. And let's see what it's doing. One thing you will already realize here that this same sand extension works for both tip collection and fee collection. It gets some tip and it computes some fee. Do you see this dispatch info that we got from based on the extrinsic that is called, and from that it gets the weight, and this weight is your what you have defined on top level. So this fee is computed and withdrawn already. Then we go to the post dispatch. Okay, it's calculating the actual fee. So now it has post info, right? That should give it like, okay, what was the actual weight that was consumed? It now computes the actual fee and then it refunds. So this correct and deposit fee, you can again look into it. I have also not really looked into it, but I am pretty sure it's what it will be doing. But yeah, you can see already that it's doing some kind of refunds. Simple enough. Now, if now seeing this, how do you think you will, or how ideally you should implement your feeless transaction? Or can you do better than what you're doing currently?
Yeah, if I could like execute something before this to tell this, hey, this user doesn't pay anything, so it wouldn't charge a fee from the start.
So what you can do is at pre-dispatch phase, read some storage and check if it has weight credits.
Yeah.
And if it has enough weight credits, don't charge. No fees, right?
Yeah.
But
I don't know how to do it, but
but what you're doing right now is basically taking fees and then refunding. The same thing. It's not so bad, but imagine I don't have any money, you still want me to have that money in the account. So it's a little bit bad, right? Yeah. And if you can imagine that you can write one sand extension per pallet, because every pallet will have different, like your pallet is giving fee-less transaction, right? Based on some weight credits. That might not be common across all pallets. So if another pallet wants to do something fee-less for some other reason, they have to define a new signed extension, right?
Before, on top of every dispatch call, we define the weight. Can we
Yeah.
put 0 over there?
Yeah,
Will that work?
but then you are making transaction fee for everyone. That's a DOS attack.
No, against only that extrinsic. On top of that, only if I put 0.
Yeah, but that extrinsic then can be called by anyone, and then it's a DOS attack, bro.
Oh yeah, that will be for anyone. Yeah.
But what you want to do is, if a user has weight credits, then allow free transaction.
Got it.
But if they don't have weight credits, charge normal fee.
Yeah.
That's the scenario. So if we go back to our slide. Okay, you already saw this. So the signed extension is actually a tuple of multiple signed extensions. So you can just keep adding as many signed extension you want. Yeah. 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 So the way it works, you charge the worst case weight, right? And now you cannot charge more than what you charge in the beginning. At the post dispatch, it only does refund. It cannot charge more fees. So if you started with 0, you cannot later charge more fees, right? Is that? Also, another thing that I didn't mention, I mean, in some ways, these are overheads. So whatever signed extension you add, it will, if it's not stateless, if it's looking at account, if it's reading some storage, it's adding some overhead to your already potentially expensive extrinsic, right? So you should be careful not to read storage as much as you can. But I mean, feeless transaction, that's your business case, so it makes sense to do that. Yeah, we saw this. You can find this exact thing in your template as well, by the way. Okay, so now there's a brand new shining feature. I think it's less than a month old since it's merged. And I could not find too many examples. So, so if it doesn't work, I'm sorry. But you should try it. It's there, it's merged, it should work. I could look with you if you're running into some problem. But I'll show you where you can find some example of this. So there is a feeless, imagine a macro that, so you don't have to create this sign extension by hand. What you want to do is something like this. So before your extrinsic, you put this condition. I should have actually put like a palette call extrinsic here just to make it clearer. Actually, let's go to the code. It's much nicer. Okay, I found an example. So what we want to do is we put a macro on top of our the call function that we have. We say this extrinsic is feeless if some condition is matched. So you pass the same parameters that you have for the function, new foo and some other compact value. And you check some condition. If that matches, if you return true, then it should not charge any fees. What it is doing behind the scenes is creating a signed extension. So you don't have to create by hand. It just creates for you. Looks very cool, very easy to do. So in this case, what it is doing, it's saying if you pass the parameter new foo as 0, this transaction is free. Otherwise, it will be this set foo benchmark. What did I miss? Anything? So in your case, what you will do, you will have some kind of storage item, like weight credits. get for that account ID, like you get the account ID from origin. I'm just writing it like this. And then check credits. Something like this, right? So you're reading your weight credit from some storage item. I'm not unwrapping and stuff, but you can understand what is happening. And then it's checking if it has credit greater than 0. You could actually be a bit more advanced. You can check how much is the weight, and is the credit enough to cover the weight. I don't know how you exactly are doing. Is it like whatever you do, one credit means one extrinsic, or is it more like you have weight credits? Okay, you have weight credits, right? So you can check your actual credits, and you can charge less fees already. Okay, this actually would not allow you. Yeah, okay, this macro will not allow you to charge a differential fee, but what you can do is, if you have enough weight credit, free. If not, then whole thing is charged by a fee. Yeah, yeah. I mean, refund is always there. So you always can return a page no as well. You can always return like a new, like actual weight consumed. So do you have any questions on this? Are you gonna try it?
Yeah. Only one. How could I check if the condition was successful in the function to then update the storage, for example? Or should I do that? Because doing it on the signed extrinsic seems
Yeah, good question. Yeah,
quite a bit of work.
you could try. I don't know. I mean, this is so new, and I
Okay.
have not even done it. So you could try to see if you can update it here, but I think you cannot.
Yeah.
But it might be possible. I'm not sure. But I guess you can assume that it will be feeless based on some weight credit here inside the extrinsic as well, and then you can just like charge the weight credit from inside the extrinsic. But no, I don't know. I mean, you should try. Tell me after you try. Okay, the last thing that I told you. So you do some work in your chain, in your runtime, and then you want to clean up something. So I gave an example where the voting period is over, the proposal is executed. Now, ideally, you want to iterate over all the accounts that took part in the voting and unfreeze them once it's executed. But that is very expensive. So what you do is you let the user have to claim back their frozen token. Does that make sense? The scenario. So can you do better? So the primitive way to do this is to create like a permissionless extrinsic, a call that anybody can call and unfreeze the user whose voting period is gone, so they are able to unfreeze, right? And then you can have like some bot, or you can think of an off-chain worker. This is a great case for off-chain worker where it can check the state who are allowed to be unfrozen, and you unfreeze them, and you can have like a pays no if certain conditions match. Again, like since this is like a cleaning task, you should not charge fees if it is correct. If somebody is calling to unfreeze someone which is actually not valid, there's no need for unfreezing, then you should charge fees because now you're computing something that you should not. Right? Make sense? So what I said in the primitive way can be done through something called palette task. I think this is okay. No, this is the correct example. So let's go to the example. Here is an example. So what you can do, you define something called a task. You define what is the task list. So you need a storage item that has like one key for each task. And what you will do from this storage item is you pick up a task, you finish it, and then you remove that key. So slowly that task will get over, or new tasks will keep getting added. Then you define a task condition. So you pass into this add number into total this I parameter, and that's your task condition. You check that your task storage item has that key. In this case, what we are doing is we are finding numbers, and what are we doing? Yeah, we are just adding total keys. Let's see what we are doing. Yeah, we have this, we have two storage items, total and numbers. Numbers is your like counter of tasks. So all these tasks you have to do. And once all these numbers are called, it will be added to the total. Very simple task. And you're defining, okay, whenever a number is called, so whatever number is called, it should be in this number storage item. Some weight similar to call, some task index similar to call. So you can think of it's similar to like a call enum. It will generate, I think the way it works is it generates one call extrinsic that can be called via system palette, and you give a task ID, but those are internal details, you don't need to care about it. What you're doing is defining a task similar to a call, and you are defining what condition should match so it executes. And then when it gets executed, you take out something from the storage. You can do it custom logic, but this is like a simple example where numbers, you can think of it as number of tasks you have to do. Once it is called, you take out that integer from numbers, you do some task, and you finish. So this palette task could be called or configured to be called from off-chain workers, or maybe your own script, which is off-chain, and it will keep calling that extrinsic to make sure whenever you have some block weight left, it keeps calling and clearing the things that you want to do. Yeah. Can you give the mic?
Does that happen just anytime, or like on idle, or like what?
So why we don't want to do it on initialize all this is because we don't know how much will be our block weight. We don't want to take up all the weight and there's no weight for the block, for the extrinsic itself, right? If we do this, imagine if you keep calling it, I mean, you can build a smarter system where it knows that it should call only one extrinsic per block or 5 extrinsic per block. So you can be smart about it. But you can also imagine that if your blockchain is overloaded, if when you send this task, it will be rejected or it will be in the pool until it gets the time to execute it. So sending it in a pool is much safer than putting it in uninitialized, but it has to be done for the same block, right? So you can imagine this is like an async process and it will happen at some point.
Okay.
Why can't we just use a normal call?
You can. So primitively, you can create a extrinsic, like a call, to do exactly same thing. But you will have to do for every single kind of task, you will have to create some kind of permissionless call to do this. This just gives you, it's like a syntactic sugar, nothing else. It just makes you do this thing in an easy way. You don't have to do it. That's the answer. Make sense? Behind the scene, it's doing exactly the same. It exposes this thing, add number into total via some extrinsic, via some call. So these are so two things I covered, this palette task and what else this feeless if. These are like really brand new frame APIs. It's like a month or 2 months old. So yeah, it would be great actually if you guys try and give feedback on what can be improved. You can actually create issues on Polkadot SDK as well if you think something is not very intuitive or easy to understand. Yeah, I think I covered everything I needed to. Does anybody has any questions? Anything?
We don't have those slides anymore. I was trying to find it.
Yeah, so this is a very last minute slides and I'll have to just format it nicely and hopefully I will commit it tonight. So you have, but the things that I showed you, I will share the links to the actual documentation links or the PR links so you can have all the details of it. So I think there is only two that you might not find in the actual slides, the feeless if and this palette task. I will send this to you. Okay. Cool. Thank you guys.